Hey dear students, today I am going to discuss about impact testing in our material testing laboratory. Impact test is a material test. In mechanics, an impact is a high force or shock applied over a short time period when two or more bodies collide. Such a force or acceleration usually has a greater effect than a lower force applied over a proportionately longer period. The effect depends critically on the relative velocity of the bodies to one another. Impact is a very important phenomenon in governing the life of a structure. For example, in the case of an aircraft, impact can take place by a bird hitting a plane while it is cruising, or during takeoff and landing, the aircraft may be struck by debris that is present on runway, and as well as other causes. It must also be calculated for road if speed breakers are present. In bridge construction, where vehicles punch an impact load, and etc. Impact tests are used in studying the toughness of material. A material's toughness is a factor of its ability to absorb energy during plastic deformation. Brittle materials have low toughness as a result of the small amount of plastic deformation they can endure. Impact testing most commonly consists of Charpy and IJOD specimen configurations. Therefore, two kinds of impact tests are discussed here. One is Charpy test and second one is IJOD test. Now, the Charpy impact test, also known as Charpy V-notch test, is a standardized high strain rate test which determines the amount of energy absorbed by a material during fracture. Absorbed energy is a measure of the material's notch toughness. The test was developed around 900 by S.B. Russell and George Charpy. It is widely used in industry since it is easy to prepare and conduct. The result can be obtained quickly and cheaply. A disadvantage is that some results are only comparative. According to ASTM E23, the standard specimen size for Charpy impact testing is 10 mm into 10 mm into 55 mm, and the specimen is Charpy test. The specimen in Charpy test is loaded in 3-point bending configuration. In our lab, for the test, we choose an ASTM E23 standard from the other various standards. Apart from that, IJO test. IJO test strength test is an ASTM standard method of determining the impact resistance of material. The test is similar to Charpy impact test but uses a different arrangement of the specimen under test. The IJOD impact test differs from the Charpy impact test in that the sample and is held in a cantilever beam configuration. On the contrary, a 3-point bending configuration in Charpy test. The test is named after the English engineer Edwin Gilbert IJOD. According to the ASTM E23, the standard specimen size for IJOD impact testing is 10 mm into 10 mm into 75 mm has been taken for our test. The impact value of a material can also change with temperature. Generally, at lower temperatures, the impact energy of a material is decreased. The size of a specimen may also affect the value of the IJOD impact test because It may allow a different number of imperfections in the material, which can act as stress riser and lower the impact energy. The impact tests are conducted on instrumented machines capable of measuring less than 1 foot-pound to 300 foot-pound at temperatures ranging from -320 Fahrenheit to over 2000 Fahrenheit. Impact test specimen types include notch configurations such as V-notch, U-notch, keyhole notch, etc. The notch in the sample affects the result of impact test. Thus, it is necessary for the notch to be of regular dimensions and geometry. The standard method for notched bar impact testing of a metallic material can be found in ASTM E23, ISO 148, and etc., where all the aspects of the test and equipment used are described in detail. Currently, in our lab, we used ASTM E23 standard for testing. In this test, the apparatus consists of a pendulum of known mass and length that is dropped from a known height to impact a notched specimen of material. The arm swings down, hitting a notched sample, breaking the specimen. The energy transferred to the material can be inferred by comparing the difference in the height of hammer before and after the fracture, that is, energy absorbed by the fracture event. The apparatus for the performing impact test is illustrated schematically in figure. The load is applied as an impact blow from a weight pendulum hammer that is released from a position at a fixed height h naught. The specimen is positioned at the base and with the release of pendulum, which has a knife edge, strikes and fracture the specimen at the notch. The pendulum consists its swing, rising a maximum height h dash, which should be lower than h naught naturally. The energy absorbed at fracture E can be obtained by simply calculating the difference in potential energy of the pendulum before and after the test, such as E is equals to mg h naught minus h dash, where m is the mass of pendulum and g is the gravitational acceleration. To perform the impact test in our lab, we have an impact testing machine of a company named as Tinius Olsen. The model number of machine is Impact 104, which is based on ASTM E23 standard for specimen testing. The machine consists of a base, a pillar on the base, a pendulum arrangement on the pillar, a hammer at the end of pendulum rod, a striker arrangement on hammer with struts, a specimen mount on the base, and a screen with encoder for the toughness readings. There are two types of striker, one for IJO test and second one for Charpy test, as shown in the figure. One specimen holder and strut tightener are also there in machine. Now we are going to discuss the procedure for the test. First, we prepare the test specimen. We put on safety glasses for the our safety. Now, after that, move the pendulum up to its locked position and ensure that it is locked in place. Place the sample in position for the Charpy. Simple lie against the stop support on both sides. with the notch facing away from the direction of the pendulum will come. For iJoD, clamp the test piece into the jig with the notch facing toward the direction of the pendulum will come, and the notch at the point of support. Now, ensure that all safety guards are in place, ensuring that the path of swing for the pendulum is clear. Now it is time to release. Release the pendulum using the release mechanism. Record the readout from the display of the test equipment. Return pendulum to its position.
A notch has to be kept opposite side from the striker or center. Potential energy.
Now we discuss about the result from the test. For our impact test, we perform total 8 number of tests. That is 4 numbers for both type of iJoD and Charpy test. Specimen material used for the test are aluminium and mild steel. 2 different tests has been performed. The total potential energy stored in pendulum at a highest position is 407.54 joules. The test results are shown in the various tables. As the results demonstrate a wide variation, as seen by the large range in the results, little can be taken from this experiment. The reason behind the variations is due to the preparation of the test pieces. They were made up by hand with little control over notching in particular. We can conclude from the results that toughness for the ductile material is high, whereas for brittle material is low. Brittle material have low toughness as a result of the small amount of plastic deformation they can endure. Apart from this, sometimes some ductile materials also shows as brittle behavior at particular temperature as transition, known as ductile to brittle transition. As you can see from the figure that for plain carbon steel there is transition from ductile to brittle at T dBt. As the transition component may cause failure. Moreover, if we add percentage carbon in steel, this transition zone increases. At the transition component may cause failure. Thank you.
देख एनर्जी अपने आप ऑब्जर्व करो, ठीक है।